Hello everybody. Thanks a lot for coming. My name is Daniel. I work for ACVO, and we are here today to talk about efficient developers. Before we get started, a reminder that if you have any questions, you can go to the website using that code and type there your question. So let's start by defining what do I mean by efficient developers. Efficient developers it's to achieve maximum productivity with minimum wasted resources. And that resource, for us developers, is usually time. So to be efficient is to do things really, really fast. Now, this definition is missing a key element that is extremely important for the kind of work that we do, that we can find in this quote by Peter Drucker. To be efficient is to do things right, while to be effective, it's to do the right things. So to be efficient is not enough just to go really, really fast. We have to make sure that the decisions that we make will not slow us down in the future. So to be efficient is to go fast, but to do things properly. Now that we have this quote here, you maybe wonder, well, what's more important, to be efficient or to be effective? Obviously, it doesn't make any sense to go really, really fast if you end up in the wrong place. But equally, if you know where you want to be, but you are never able to reach that place, it's equally a waste of time. So both things are important. In fact, there is some synergy between them. The more efficient that you are, the less time that takes you to do things, which means that you have more time in your hands to stop, look around, and make sure that you are going in the right direction. So to be efficient, it allows you to be more effective. Now, for this talk, we are just going to focus on what it means for us to be efficient. So there are several studies that try to quantify what's the impact of interruptions on us developers. And it seems that the cost is quite high, between 10 and 15 minutes. So every time that you are interrupted, you waste 15 minutes to load back into your head the context of the task that you were doing before you were interrupted. So to be efficient, it's paramount that we reduce the number of interruptions to the minimum. So we have long periods of time where we can focus on the task at hand. There are basically two types of interruptions, the ones that you control and the ones that other people control. Of the ones that you control, email notifications is probably the worst offender. If you think that that little pop-up doesn't do anything for your concentration, the truth is that for your brain, it looks more like this. Millions of years of evolution have made our brain really sensible to any kind of unexpected movements, mostly because of the fear to be eaten by other animals. By the time that pop-up disappears, you have already read the subject, the sender, and your brain is already working on it. So the first habit of efficient developers is to disable all notifications. So not just email notifications, but all notifications. In fact, you don't want to even see in your desktop the number of unread notifications. The only notification that you actually want to see is the one that tells you that you broke the build. Email is asynchronous, right? So it's more efficient to deal with it in batches. And nobody should expect for you to reply to emails immediately. If you are using Slack or Skype or whatever other email messaging system, you should always think that if you really want to go and ping your teammates, instead of just sending him an email, because if you ping your teammate, you're going to probably interrupt his workflow. So you really should think if it's more efficient, if it's better just to send him another email. And please never, ever be one of these guys, that they send you an email, and then they run to tell you, to ask you if you have read email, or they call you, or you're pinging on Skype. This is extremely, extremely annoying. This brings us to the second type of interruptions, the ones that other people control. What can you really do when somebody comes to your desk to interrupt your flow? I can think of three possible options. The first one is to wear some headphones, and the bigger, the better. So that when somebody comes to interrupt you, you just pretend that you didn't see him, with the hope that he will just go bored and he will walk away. The second option is to have a very good team lead, somebody like this guy, somebody that is able to tackle any interruption before it reaches the team. And the third option is to do pair programming. When you are doing pair programming and somebody comes to interrupt, what should happen is that one of the developers in the pair should stand up, walk a couple of meters away from the pairing station, and handle the interruption. And when he's done, he will go back to the pairing station. And the developer that managed to keep focus on the task works as a really, really fast cache that will make the developer that was interrupted productive again in no time. Also, if you are doing pair programming, you have the additional benefit that because you have somebody there looking at you all the time, you're not going to check your email or your social media that often. So that peer pressure of somebody looking over your shoulder all the time is going to make you more efficient because it's going to force you to be focused for longer. Well, I don't think I need to explain this, right? We all know it, and I don't want to sound like your mom telling you to eat your greens. So let's move to the next one. Efficient developers, they do one thing at a time. And the reason is exactly the same as why we hate interruptions, because of the context switches. Oops. Here, we see that doing the blue task after we have finished the green task, it takes less time, right? Because there's just one context switch. But doing one thing at a time is not more efficient just because it takes less time. Usually, the quality of your work, where you are trying to do multiple things at the same time, suffers. Remember that the definition of multitasking is screwing several things at once. So focus on one thing, finish it, and once you are done, you can move to the next. As developers, we are going to spend thousands upon thousands of hours using our ID. It's our main tool. So it's really critical that you know it inside out, because any efficiency that you get using your ID is going to be multiplied by those thousands of hours that you spend in front of it. Just basically need to know two things: its functionality and the shortcuts to use it. Now, just because you are already sitting in front of your ID 6-8 hours a day, it doesn't mean that you are going to master it. To master your ID, you need to make a conscious and deliberate effort to learn its functionality, to learn what you don't know about it. There are several ways of learning about it. You can read the release notes, you can read the documentation, you can follow blogs and YouTube channels of people using that ID, or you can also do pair programming. When you do pair programming, you are going to see how each of your teammates uses the ID. So you are going to be learning the functionality from them. You are also going to see how they do some tasks. So maybe they do it in a more efficient way. And you're also going to have the opportunity to show them all the tips and tricks that you know, making the whole team more efficient. I'm always surprised about the amount of manual work that we developers are able to put up with. And I found it quite paradoxical, given that we are basically paid to automate other people's job. Yet we fail to do the same with our work. Doing the same manual task over and over is not only time-consuming. Manual work is boring, dull, and it's error-prone. So I always wonder, well, why we keep doing it? I think that we sometimes forget that we are developers. And as developers, we have this really powerful and rare skill that allow us to create an army of minions that will do exactly as you want. They will not complain, they will not get tired, and they will do really, really fast. And I think we don't use this skill in our own benefit often enough. Oops. Oh my God. Maybe it's because the minions that we create, they behave more like these guys, but that's subject for another talk. Just to make sure that it sinks, I'm going to say it again. You are developers. You should never, ever do something that your computer can do for you. The first thing that you should do before starting any task is think if you can write a program to do that task, or at least to help you to do that task. And I'm not talking here just about automating some task that takes you hours or days to do. I'm also talking about those tasks that take you maybe 5 seconds, but you do very often. In fact, I'm also talking about writing programs for those one-off tasks that you're never, ever going to do again. First, because probably it's more efficient, but second, because I hope that writing a program, it's a lot more fun than do things manually. To write simple programs, there is nothing like all good Bash. On my 19 years as a professional software developer, I have changed programming languages, I have changed IDEs, I have changed operating systems, I have changed my mind about all kinds of practices and ideas. Bash has been the only thing constant over those 19 years. I want to do a little demo about what Bash can give you. So let's say that your product manager comes and tells you that there is some other team has written an application and is collecting news from several sites and is putting it in some server. And this manager wants to know how many news for each country we have. So you jump into the box, and the first thing that we are going to do is write a little program. So the first thing that we are going to do is know how many news we have collected so far. Yeah? So that little thing over there, that's actually a program, right? So let's see what do we have here. So we are going to check one of the news. It's a piece of JSON. So let's format it so we can have a better look. So it's a piece of JSON, and we see here that there is some tag with the country. Yeah? So let's try to extract that country. I'm going to do brute force, but so let's try to find the country. That is the country, yeah. So let's try to extract just the country. Okay, I could try to make a better grep, or I could try to use GQ to extract that field, but we are going to go a little bit brute force. So we cut now the line using the delimiter as delimiter the quotes, and we want the field, the third or the fourth field. So we want the fourth field. Cool, so now we have a little program that is able to extract one country. So let's see if it works for all of the news. Seems that it works. And now we just need to sort it and count it. And let's sort it again. So we have it ordered by the number of news. So that's a little program. It takes you no time, right? You don't need to copy all those files into your local disk. You don't need to create a Java project. It's very, very simple. Now let's say that apart from the country, we want to know how many news per website we have. So we look at the site. Those are the news per site. Now let's get a little bit more fancy. Let's try to find out for each country what are the top 3 sites with most news. Yeah, for each country, the top 3 sites. So let's find first for one given country. So we are going to try to find all the news for one given country. That in this case, we're going to try Israel. Does that work? Cool. So, and now we want to reverse it, and we want to actually get the first 3. Cool, and we are going to format it so everything is in one line. Here it is. So we have a little program that for Israel, it tells us what are the top 3 news sites. Now we just need to do this for each country, right? That's just a for loop. So I copy that. Let's try to get it. What is this country? These are all the countries. Now for loop. We're just going to print first I, so I know that I haven't made any mistake. That works. Now let's paste. So, okay. Now everything is Israel, so I just need to change this li for the variable. And because we are in bash, we have to play the quote-unquote game. Quote, 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 unquote, quote, quote, unquote. And there it is. So the first thing is, bash can do a lot of, with a very small command set, you can do a lot of stuff. And you get this really fast feedback that you do one little bit and you see it works. I hope that gives you an idea about what bash can do for you. A word of caution, before you start writing any program for yourself, the very first thing that you should do is time limit the amount of time that you are willing to put into that program. Because it's just too easy for us to go and just get lost on time trying to finish the application. So you have to make sure that after that time, you have consumed that time, you have to be willing to give up and go back to do things manually. Now, even if you are not managed to finish that application for you, you should never think that that's wasted time, that you waste your time by trying to write that application. You should think about that time as time that you are investing on yourself, that you are making yourself more productive. So you are doing little investments to make you a better developer. And if we are talking about writing programs, you will want to avoid graphical user interfaces. Why? Because you cannot put a UI inside a for loop. UIs cannot be part of any automated pipeline. UIs do not compose, because UIs live in their own little isolated world. Now, I'm not saying that you should never, ever use a UI. They are extremely useful when you are learning something new, when you are a beginner. But once you want to go past that beginner phase, UIs just constrain what you can do and what you want to see. So at some point, you will want to free yourself from the UIs. And if we are talking about avoiding UIs, the first UI that you want to avoid is your own application UI. There is nothing less efficient to know that you didn't break your application, that started, click things around, filling up forms. That's just a big waste of time. But our automated test suite doesn't only save us the time, the boredom of doing the same task over and over, the same test over and over again. They also give us the confidence to refactor our code. And they also work as a documentation to know that, what the application should do. But most important, an automated test suite, it picks up bugs. And bugs are really one of the worst time wastes. First, you need to write the bug. Then somebody has to go review it. Then you need to go through the process of putting that bug into production. Then a user has to report it. Then you need to triage it. Then you need to explain it to your QA, to your manager. You have to create a Jira issue. You need to prioritize it. And then you can go and fix the bug. But this time, probably, you have gone through this massive context switch. Because even if you write that code yourself, probably you wrote it several weeks ago. So that code is already legacy code. And then you fix it. You have to go review it. Somebody has to QA it. And then you need to put it into production again. So all of it, big waste of time. But of course, worse than a bug, it's putting the same bug twice into production. So whenever you have a bug, the first thing that you should do is write an automated test that proves that you are able to reproduce the bug. And once you have the test and you see it fail, then you can go and fix the bug with confidence. And the last thing, boring manual task that you want to avoid is setting up the development environment for your application. This is not only going to make you more efficient, it's going to make the whole team more efficient. Whenever I join a new team, this is the kind of instructions that I found on the wiki to set up the application. And the only thing clear about them is that they are not going to work. Probably they are out of date, but even if they're not out of date, it's quite possible that I'm going to make a mistake when I try to follow them, or that I have already installed something that it makes some incompatibility with those. What you should aim for is just one single command. That single command should install and set up all the tools that you need to build, run, and test your application. So if your application needs a database, that command should install the database, configure it, and it should set it with some useful data for development. If your application needs JDK, Maven, all those things should come and should be installed as part of that one command. As you can see, my tool of choice right now to do that is Docker Compose. If you're not familiar with it, Docker Compose is part of the Docker suite, and basically allows you to define an environment with just one simple file. There we are saying that we need a Postgres database, a Redis server, and then our own application container. Now, apart from the fact that it's going to take a new developer minutes to get started, to be able to contribute to the project, there are some other benefits of using Docker. The first one is because all the tools are part of the container, you are making sure that everybody in the team is using exactly the same version of Java, the same version of Maven, with the same version of the operating system. And those versions probably, they should be the same as the ones that you use in production. So you are removing a bunch of possible issues. Also, these kind of instructions, they never ever get out of date. Because if you need a new component, what you will do is change that file, and you will just commit it. And then the whole team will be able, in a few minutes, to have the latest version of the development environment. Also, if you are working in several projects at the same time, Docker Compose creates each of the environments that creates there, it's isolated from the rest. So you can have completely different versions of Java, Maven. It doesn't matter because the environments are isolated. And because it's very easy to clean up, destroy your development environment, you are going to be more willing to experiment with new versions of Java or Postgres. Because you know that if something goes wrong, you just wipe out the whole environment, revert the file, and then you are ready to go. Okay. Feedback is going to tell you if you are going in the right direction. So you want feedback early and often so that you don't wander on the wrong path for too long, with the consequent waste of time and energy. We already talked about how important an automated test suite is, but when is the best time to actually write those tests? I'm going to give you 4 reasons why writing them before the code on a TDD style makes the most sense. The first reason is the fast feedback that you get with the TDD workflow. You write one test, you run the test, you see it fail, and you are getting some feedback. You write just enough code to make the test pass, you run the test suite, and you are getting feedback. You do a little bit of refactoring. You write the whole test suite, and you get some feedback. You do a little bit more refactoring. You run the test, you are getting some feedback. So you are moving in very tiny steps, so that if something goes wrong, something stops working, you know that the issue is with the last step. And that step is really, really tiny, which means that it's very easy, very fast to find out what's the cause of that issue. The second reason why you want to write your test first is that the automated test suite is an investment, right? It's not free. You have to put some time into building it and into maintaining it. Because it's an investment, when is that investment going to pay off? Test suite pays when he picks up some bug when it's able to catch some bug. And when it's going to catch some bug? When you can introduce some bug? When you are changing the code. Now, if you write your feature first, and after that you write all your tests, that test suite, if you never ever touch the project again, or that particular module, that's just a big waste of time. That's the worst investment that you can do with your time. Now, if you write your test first, you are changing the code there, right? So the test that you are writing, that investment that you're doing is going to pay off immediately. So even if you don't touch that code base ever again, the tests are a good investment. So if you think that automated tests are worth the time, you should always write your test first. The third reason why you want to write your test first is an organizational reason. I've heard plenty of times the phrase, well, I don't have time to write tests, or I'm not given the time to write tests. And for me, whenever I hear that, what I really understand is that, well, you're first writing your feature, and then at the end, it's when you go and write your test. And if there is any time pressure, and there are always time pressures, what do you stop doing? What do we don't have time to do? Obviously, the thing that is not done yet, which are the tests. And because you don't have a test suite, it means that you are not doing a lot of refactoring. Because to refactor, you need to have a very good test suite. And because you don't refactor, it means that your code starts to accumulate more and more garbage. And the more garbage that you have in your code base, the longer it takes to implement new features. And the longer that it takes to implement new features, the more time pressure that you get, closing a vicious cycle that it always ends up with us developers crying for a rewrite. And the fourth and last reason why you want to write your test first is a mechanical reason. Because seeing a test fail is the test that tests if the test tests what it's supposed to test. Or in other words, how do you know that your tests have no bugs? If you write a test, you run it, and you see it fail, then there is a strong indication that there is some missing logic in your production code. If you write a test and immediately it's green, you're not sure it's because you already implemented that feature, or because there is some bug in your assertions, or some bug in your setup code. Now, when you present this idea about writing tests first, a lot of people come back with, well, I cannot write a test first because I don't really understand. I don't really know what I'm going to build. Now, this can mean several things. It can mean that you really don't understand what business is asking you to do. And in this case, it's true that you cannot write a test first. But you cannot write any production code either. What you have to do is go back to business and ask them, well, what I am supposed to do. The other case is that you actually understand what business is asking you to do, but what you mean is that you don't know if you're going to write one class, 10 classes, if you're going to use a if statement, or if you're going to use a factory. You don't know the structure of the code that you're going to write. You also understand what are the side effects that you need to produce. And by this, I mean you are going to use a database that you have already used 10,000 times, and you know it inside out. So you understand how that database is going to behave. In all these cases, you can actually write unit tests first. Now, it's true that sometimes we don't understand the mechanics of the side effects that we need to produce. Maybe you have never, ever used this new NoSQL database. Or you are going to use a database that you have never seen again, before, and you don't know which tables does it have, what are the possible values, what you can get out of that database. Or maybe you are using a new library, and you have never played with it. With a GMS library, some concurrency, you don't know how the mechanics are going to work. In this case, I think TDD doesn't really help. And in this case, you cannot write a test first. What we want to do is write loads and loads of little programs to convert that unknown side effects into known side effects. This is the kind of exploration phase, I call it exploration phase, where you want to close that knowledge gap between unknown and known. To do this, the best tool that I know, it's a REPL. REPL stands for read, event, print loop. And basically, it's the same as a Unix bash shell, the same ergonomics, but instead of using bash, you're using your production language. Instead of trying to explain it, let's see a REPL working, hopefully. So I already started an application. This is a war running inside a Tomcat, and inside that application, I started a REPL. I'm going to use Clojure, doesn't matter the language. And what I'm doing from my IDE, I'm connecting to that running application. So let's say that you are going to use a new library that you have never used again before. So with a REPL, what we are going to do is you write little pieces of code, and you want to know how it works. So let's say that you don't know how plus works. So you write a little program, and now I'm going to use a shortcut to get this piece of code, send it to the REPL. It's going to be evaluated. It's going to be run by the REPL, and it's going to tell us the answer. So I hit that shortcut, and we see here what we sent to the REPL and the result. Okay? Let's see what happens. Instead of 2 parameters, you pass 3 parameters to your plus function. Seems to work. What happens if you send a very long number? It seems that we get an exception. What happens if instead of 3 parameters, I just pass 1 parameter? Well, that seems reasonable, and no parameters. So what are we doing? We are writing little programs to help us to understand how, in this case, a library works. So we are going through a really fast feedback loop where we don't need to compile, we don't need to wait. It's an immediate feedback. So then let's do something a little bit more fancy. Let's say that you want to explore some HTTP endpoint that is going to return you Forex exchange. Let me see if I get that right. Cool. It's going to return you some Forex exchange. So now I'm making an HTTP call. Yeah? We all know how to make a HTTP call in your favorite programming production language. So that's returning some exception. So let me see. Let's catch the exception. Catch exception. And let's see what the exception is telling us. But being default catch exception. Try. So we see that we're getting a 400 from this endpoint. And we see here that there is somebody saying that is missing a required key. So let's see. What it's telling us basically is that we are missing query parameters. So we need some date. Let's see if it works with number 3. And we are getting a body, seems some kind of JSON. So let's get that body out. Now, come on. As a string, let's parse that. Cool, that's it. So see what I was doing. I was making one little change, and I will run it. I will make another little change, and I will run it, just to make sure that in each of those little steps, I am not making any mistake. And I do all of this without having to wait for anything to compile or to run or to start anything. Now, you may be wondering, well, why we are not using something like Postman, right? Where we're doing some HTTP requests. Why we don't use Postman instead we are using a REPL? How here with the REPL, we have our production language. We have a whole language to do whatever you want to do with it. I personally don't know how to do a for loop with Postman. Also, if you need to mix this data from HTTP with some data in some other database, here we have the whole JVM with all these libraries to be able to go and mix and match data from any source. If you were using Postman, you'll have to get, I don't know how to do a for loop, but you will get the data from Postman, and then you will need to get the data from the database and try to mix it. It will be very annoying. Now, there is another additional benefit that if I go now and I wrap this thing into a function, this is production code. This is how I will deploy. This is what it will go to production. So I don't need to translate what I was doing in Postman to Java or to my whatever you're using in production, because here, out of this exploration phase, we are actually getting production code, production-ready code. And the changes that I'm doing, these are in the project. These are part of the source code of our application. So I don't even need to copy and paste to any place. Also, we are connecting to this REPL through a network socket, which means that we don't really need to be running this thing in our local box. We could do the same in our test environment or a production environment. So you could connect from your IDE to your production, make changes, look how the data that is flowing through your application, what's the state or anything that you have in your application. It's like having a debugger attached, ready for you, with the whole power of your production language ready to be used. Now, if this still doesn't make any sense, I did a talk last year at GeeCON where I explained this in more detail. And the last thing that we are going to talk about is code reviews. Code reviews basically give you the opportunity for your teammates to give you some feedback about if your design of your code, it matches the design of the application, if you have any bugs. So efficient developers, they want the code to be code review. Now, there is something very true behind any kind of code review. When you are presented with this massive pull request with hundreds of changes, I don't know what's your reaction, but mine is something like, oh my God, why me? Why didn't you choose somebody else? But when you see one small pull request, you are actually able to give useful feedback to the author of that pull request, right? Because basically, you are able to understand the change. Now, even if you are a very disciplined developer, and you go through that painful process of properly, and I'm saying properly, reviewing the change, what usually happens when you go and tell the author, like, well, your code is shit. Sorry, your code doesn't fit the design of the application, or your solution is really, really bad, or you should use this other library that will save us, half of the code. Even if the author agrees with you, which he never does, but if he agrees with you, he usually comes with something like, well, I've already been working in this massive pull request for days or weeks. And what you are suggesting is going to take me several more days or weeks to do. And the end of the iteration is tomorrow, so I don't think I'm going to have time. Also, the code is already working, so why don't we do something instead? We commit or we merge the pull request as it is, and we are going to ask our product owner to create a refactoring story, right? I'm sure that he will be delighted to put that story on the top of the priority queue. And we all know that that never happens, which means that you end up just committing the code as it is, which means that you end up with more garbage in your code, which means that it takes you longer to implement new features, and you know how this is going to end. So efficient developers, they don't want code reviews. They want the code reviews to be really, really small, and they want code reviews early and often. So what they really want is continuous code reviews. This technique consists on getting one of the teammates to sit just with you in your same desk. And as you are typing, as you are implementing a new feature, this other developer is going to give you feedback about the code, about how to improve it, about possible alternative solutions. It's going to be pointing out to edge cases that you didn't take into account. So it's going to give you that really early feedback. Also, as a reviewer, the changes that you have to review, they are really, really tiny, because you see them appearing in the screen. This technique has the additional benefit that if for whatever reason you are not able to finish the task, the developer that was sitting with you, he will have no trouble on picking up the task, because he has been behind each and every decision that you made. So you are avoiding knowledge silos within your team. And the last benefit is that this developer that's sitting with you, he can work as your personal Stack Overflow. If you have any trouble, maybe he has already gone through it. And he can even help you without you having to ask the question because he sees what you are going to do. Some people call this technique pair programming. So that's all that I have. Very briefly, focus, master your IDE, your tools, avoid manual work, and find yourself the fastest and closest feedback possible. And last words, you should always find time to stop, reflect on how you are working, and never, ever stop learning. Thank you very much.